Good day, viewers at home. In case you are hearing my voice for the first time, I remain Engineer Will.I.am plus S. This is a continuation of our class on motion. So we have a question here, and this question is a kind of question referred to as instantaneous speed or velocity. So the question says a body starts from rest and moves with uniform acceleration. Starts from rest, you have initial velocity to be 0. And moves with uniform acceleration. So the acceleration here is 6 meter per second square. Then I ask us to calculate, so what distance does it cover in the third second? So the time here will be not 3 seconds, but just say third second. It's not the same thing as saying 3 seconds. It's not the same thing as saying 3 seconds. A body starts from rest and moves with uniform acceleration of this. So what distance? So we're looking for distance covered. So this third second and 3 second is not the same thing. So whenever they ask you to calculate distance in third second or fifth second, you are simply asked to, or how do you do it? You solve the distance for 3 seconds and also solve the distance for 2 seconds. The answer you get, find the difference. That is the answer to the question. So for instance, now in this question, we're asked to calculate the distance covered in third second. So we're going to solve for 3 seconds and 2 seconds. Then we subtract the answer we get to have the answer here. So we can start by saying that S equal to UT plus 1 over 2 AT square, because it contains all the variables there. So what is our distance? We don't know. Remember, initial velocity is 0, so 0 times time will be 0. So we have 1 over 2 AT square. So that distance covered will be 1 over 2 times the acceleration here is 6, then times the time here is 3 seconds. Remember, it is square. So 3 square minus, we also solve for 2 seconds. Then we have distance covered will be 1 over 2 times this will give us a 3 times 9. 3 square is 9 and 2 square is 4. 9 minus 4 will give us 5. 5 times 3 will give us 15 meter. So that is the distance covered in the third complete second. So if the question was fourth second, what do? You solve for 4 seconds and 3 seconds, subtract the answer. If the question says 10th second, you solve for 10 seconds and 9 seconds, then subtract the answer you get. That is how you solve this kind of question. I believe that is clear. The next question I have here says two particles x and y starting from rest. So if it starts from rest, you know that the initial velocity is 0. Let's say solution is here. So two particles x and y starting from rest cover the same distance. So distance they cover is the same thing. Let's call it 1. They covered 1 meter, or just say s meter. They cover the same distance. The acceleration of x is twice that of y. So acceleration of x is equal to 2 and that of y is equal to 1. So it is twice. Then the ratio of the time taken by x to that taken by y is. So what do? You can start by analyzing equation. The equation to use here is s equal to ut plus 1 over 2 at square. But your initial velocity is already 0, which means that 0 times t will give us 0. So you have s equal to 1 over 2 at square. Or you say that distance is equal to at square over 2. So if I cross multiply this now, I'm going to have 2s equal to at square. So that t square will be equal to 2s over a. Then t will be equal to square root of 2s over a. Then what are we looking for now? We're looking for time of x divided by time of y. Remember ratio. They said the ratio of time taken by x to that taken by y. So it's going to be tx over ty. The time taken by x divided by time taken by y, which will be, then this here is the time taken. So the time for x will be square root of 2s over a divided by the time taken by y will also be the same thing, 2 square root of 2x over a, which will now be equal to 2 times distance is 70, let's call it 1, divided by the acceleration of x is twice, which will here will be 2, divided by that of y, 2. The distance is 17, which is times 1, divided by the acceleration of y is now 1. Remember, the acceleration of x was twice that of y. So that tx over ty will be equal to 2 times 1 will give us 2, and 2 divided by 2 give us square root of 1, divided by 2 times 2 will give us, 2 times 1 will give us 2, divided by 1 will give us square root of 2, which is something as saying square root of 1 is 1, then square root of 2 is square root of 2. So you have 1 over root 2 as your answer. So the ratio of the time taken by x to that of y is 1 root 2, or you can say 1 ratio root 2. That is the answer to the question. I believe it's understood. Next question. So the question says an object falls freely from a height 25 meter onto the roof of a building. So the first height was let's say 25 meter, and the second height was 5 meter. So which means the main height, the height from the height to the roof of the building is h equal to 25 minus 5 meter. An object falls freely from a height of 25 meter onto the roof of a building. So it falls from a height to the roof of a building, and the roof of that building is 5 meter from the ground. So what are we doing? We subtract the height of the building from the total height, which will give us 5 meter. They say calculate the velocity, which is final velocity, with which the ball strikes the roof. Calculate the velocity with which the ball strikes the roof. Then we have g as 10 meter per second square. So what else do we have in the equation? We have height, we have this. So which of the equation, the motion can do this for us? So we can say that h equal to, or v square equal to u square plus 2gh. That is the equation to be used. So that our v we don't know, equal to our u, that is initial velocity there, is 0 square plus 2 times 10 times the height there is 20. So that v square will give us 2 times 10 times 20. V will now be equal to, this will give us 400. So v will be square root of 400. Square root of 400 is equal to 20 meter per second. That is the answer to the question. So the speed at which the object will strike the roof is 20 meter per second. That is how you solve such question. I believe it's clear. The next question I have here is, this one looks a little different from the ones we've been solving, we solved previously. So the distance x meter traveled by particle in time t second is described by the equation. So we have equation here, and the equation says x, the x represents the distance, equal to 10 plus 12t square. Find the average speed of the particle between the time interval t equal to 2 seconds and t equal to 5 seconds. We have a lot of options here. So if you look at this equation very well, none of those equations of motion can solve it for us. So the best thing we do here is to differentiate this particular equation. How do you differentiate? I'm going to show you just two rules we're going to need here. The first rule of differentiation is that derivative or differentiation of a constant value is equal to 0. What is a constant? A constant is just a number without variable. So if I write 20, 20 is a constant. So if I differentiate constant, my answer automatically becomes 0. So any number without variable is known as constant. So whenever I differentiate a constant, my answer becomes 0. The second rule is that whenever I differentiate in a polynomial, let's say you have y equal to s raised to n. So if I differentiate y with respect to n, the power will come to multiply this. So you have the y over the x. The power will come to multiply to give us nx raised to n minus 1. So this comes to multiply this raised to the power minus 1, no matter what the value may be. But the value of n must be more than 0. So you can subtract it. So if I have something like, let's say y equal to s raised to power 3. If I'm to differentiate this now, have the y over the x will give me, this comes to multiply this to give us 3x raised to power 3 minus 1, which is 3x raised to power 2. So I have differentiated this. If I'm to differentiate something like this, let's say v equal to t raised to power 4. This is something I say dv over dt. So I'm differentiating v with respect to t. But in the other case, I'm differentiating y with respect to x. So this will become 4, come to multiply t will give us 4t raised to power 4 minus 1, which will be equal to what? 4t raised to power 3. That is how you differentiate. Let us now go back to the equation and use it. So the equation is described by x equal to 10 plus 12t raised to power 2. That is the equation. And we are asked to find the average speed of the particle between the time interval t equal to 2 seconds and 5 seconds. So we're going to solve for 2 seconds and 5 seconds, then we take the average. So dx over dt. So if I differentiate distance with respect to time, it is going to give me speed. That is what it is. So this will be, this, remember this is a constant, it becomes automatically 0 plus this will come here to give you 24t. So dx over dt is now 24t. Remember they said the time interval is 5 seconds and 2 seconds. So I substitute t with 5 and also with 2. So this will give us 24 times 5. 24 times 5. So if you multiply 24 by 5, we are gonna have 120. That is meter per second. Then also we are gonna have, again, this is for the 5 second time interval. Then for 2 seconds, we are going to substitute our t with 2, so which will be 24 times 2. If you multiply 24 by 2, you are having 48 meter per second. And we are asked to look for the average speed. Average speed. What is average? Average speed here becomes 120 plus 48 divided by 2. So if you add 120 to 48, we are going to have 168. If you divide 168 by 2, we have 84 meter per second. That is how you solve question like this. If any of the equations of motion cannot solve it for you, just differentiate it. So when you differentiate, and that you need to know is that sometimes you may be given questions like, let's say x is equal to 2 plus 4t raised to power 3, and you may be asked to look for the acceleration. So let me just put it this way. The distance traveled by particle is represented with this equation. Calculate the acceleration after, let's say after 2 seconds. Let's say after 2 seconds. So if you have a question like this now, you are differentiating these 2 times. You're using higher derivation, which means if I differentiate the x with t, with respect to t, whatever I have here is now velocity. So which will give us, this is already 0, then this will be 3 times 4t raised to power 3 minus 1, which will be 12t raised to power 2. So what I have here now is velocity, because if you differentiate distance with time, you will get speed or velocity. Then for me to get acceleration, I have to differentiate this with respect to this. So dv over dt will now be 24t. So this is now acceleration. So what do you do next? You will now substitute with that 2 seconds, which will give you 24 times 2, which is 48 meter per second square. That is how you solve question on instantaneous velocity. Thank you for watching. Kindly subscribe. See you in our next video.